Okay. Hi guys, today we're going to be talking about 4.5C mixtures and solutions, okay? So there's two things we're talking about today, again, mixtures and solutions. Both have some things in common. They're both mixtures, which means they are comprised of two or more ingredients or substance mixed together. Yeah, they're both mixtures, two more, and they both can be separated. Now, some of the key differences of a mixture are it's heterogeneous. Heterogeneous means that it's not mixed evenly. Take, for example, trail mix. If I grab trail mix in one hand, I might get like 3 raisins, 5 peanuts, and 1 M&M. Then I reach again to the same bag of trail mix, I'm going to get 5 M&Ms, 1 raisin, and 1 nut. So it's still a mixture, but every time I reach in, I'm going to get a different amount. So it's not mixed evenly. And a plain mixture can be separated easily. There's very little energy needed to separate that mixture. All right. The different size and particles for a mixture, they keep their physical states. That means that when I mix them or do anything to them, they're not becoming a liquid, they're not becoming a gas, they're keeping their exact physical state of matter. All right. Now for solution, so some key differences. This is homogeneous. Homogeneous means that they are the same all the way throughout. This would mean like chocolate milk. If I take a sip of chocolate milk at the very top, or I get a straw and take a sip from the very bottom, it's going to taste the exact same. Even though it's a mixture, it's mixed throughout the whole thing the same. So no matter where I take a sip, or no matter where I took some, it's going to taste and be the exact same. Examples of these would be lemonade, Kool-Aid, sugar water, any kind of solution on there. And another thing about solutions is they are harder to separate. You have to add energy or something else to get them to separate, not as easily as a regular mixture. Now, when talking about a mixture, there's two key terms, or a solution, excuse me, there's two key terms we always talk about. We talk about solvent and solute. A solvent is what's going to do the dissolving. So if I'm making Kool-Aid, I have my Kool-Aid powder and I have my water. The water is the solvent. This is what's going to dissolve that Kool-Aid powder. The Kool-Aid powder itself is the solute. That's what's going to dissolve. Okay? Now, key things to think about dissolving that people forget about is that it just doesn't magically disappear. Remember that when you stir and you dissolve particles, they're just actually getting smaller and smaller and smaller. Too small for us to see with our eyes, but they're still there. That way, if I evaporated the water out for my Kool-Aid, the powder would still be there, even though it turned into a liquid when I started to dissolve it. All right, so that's it for mixtures and solutions. Have a good day. Science.